So just to confirm what that graph looks like, you can plug in to your calculator this equation. So I'll type it in exactly as is, negative 2 times x minus 4 squared minus 18. And I need to use a pretty extreme window, so I don't really care too much about stuff to the left of the y-axis. So let me use a window from negative 2 to 10. And I'll look as far down as negative 60. And let me change my y tick marks to be every 10 units, just like we did on paper. Alright. So there we've got our y-intercept at negative 50, our vertex somewhere in the neighborhood of 4, negative 18. You can calculate or trace that maximum. In this case, we would need to find the maximum of our graph. So that is pretty consistent with what we graphed by hand. And that is how you would handle a function given in vertex form. So the beautiful thing about having these two different versions of a parabolic equation, or quadratic function, is that now allows us to reverse engineer the equations based on the parameters described. So here we have an example where we would like to find the equation of a certain parabola. We're told it passes through the point 0, 5, but its vertex is 2, 2. So remember our two forms. We have y equals ax squared plus bx plus c, where a, b, and c are connected to these data. But we also have ax minus h squared plus k, where h and k are the coordinates of the vertex. So I think this form is going to be more useful to us because we can already figure out two of the three data which describe exactly how the parabola will look. So notice that h is 2 and so is k. So we can substitute those in and say, at least we know x minus 2 squared plus 2. So things that can happen to our parabola, we can move them horizontally and vertically, and we can stretch them or reflect them vertically. Reflecting horizontally doesn't really do much with a parabola, and doesn't really manifest very often in the equation, so we don't worry too much about that. But that is why we have this a. This parabola is not necessarily equally stretchy to y equals x squared. This parabola might be stretched vertically or compressed, or it might even be reflected. Just to kind of see what we're dealing with, let's sketch out these 2 points, 2, 2, and 0, 5, and that's the parabola we're trying to find the equation for. It's not a very good drawing, but at least we know it's concave up, which means that a, when we do find it, should be positive. But that doesn't tell us much. A could be 1, a could be 40. We have no way of knowing at the moment. But we can use the fact that this point is a solution to this equation. If I plug in 5 for y, and 0 for x, then the only variable left is a, and we can solve this equation for a pretty easily. So let me move 2 over to the other side. 3 equals a times negative 2 squared. So 3 equals 4a. And so if we divide both sides by 4, we find that a equals 3/4. So our final equation is going to look something like y equals 3/4 times x minus 2 squared plus 2. Now these are really good ones to plug into the calculator when you're done and make sure that it matches up. So if I plug in 3 over 4 times x minus 2 quantity squared plus 2. And I'll use a standard zoom, since I still have this weird zoom from the previous problem. There we go. So that looks similar to what I kind of sketched out here, but let me make sure this satisfies all of the criteria. We want to see if it contains the point 0, 5 and 2, 2. That's all that we know this parabola is supposed to do. More strongly than that, we know that 2, 2 is supposed to be the vertex. So if I calculate this minimum that I'm seeing here, and that vertex is not 2, 2, then we did something wrong. Well, I'm getting a little rounding error, but this is close enough that I would conclude that we are okay as far as the vertex goes. So the vertex is on the graph where it's supposed to be. Let me trace along the graph, and I'll come over where x equals 0, y equals 5. So there we go. 0, 5, and 2, 2, the vertex, are both satisfied. It's not enough for the graph to contain the point 2, 2 and the point 0, 5. 2, 2 has to be the vertex. But by verifying that the minimum of this graph is indeed 2, 2, we have made sure that we have the vertex at 2, 2. So that is the general approach we want to use when we're working backwards from these parameters. So that is all that I want to touch on for this section. Get started on those homework problems and bring any questions you have to class.